This Git mini presentation will be on collaboration, so how teams and individuals work together. So let's look at some different high-level models. First of all, there's the centralized model, which is very simple. You just have a shared repository. All the developers work with that, pulling and pushing to and from it. It's nice and simple, but as you can see, it doesn't scale. It might work with half a dozen developers, but it's certainly not going to scale to hundreds. What does scale to hundreds is the Dictator model. So this is, of course, the one that Linus Torvalds uses to control Linux. So basically, you have an authoritative repository, and only the Dictator pushes to that. Only the Dictator actually controls that. And then you have a few developers, maybe dozens, maybe thousands in the case of Linux, and they pull from this authoritative repository because they know it is the latest copy and the one that they want. And they push to lieutenants. So there can obviously be several tiers of lieutenants, scaling up to however many you want. In the case of Linux, he only has about a dozen lieutenants, who I think in turn do have their own lieutenants. So basically, developers push lieutenants, and the Dictator only takes pull requests from the lieutenants and then pushes back to the authoritative repository. Here's another one, peer-to-peer. So each developer has their own private and public repositories, and the way that they interact is that they pull changes from each other's public repositories and merge in that way. The integration model is something you might use when you want some control over your team of developers. So basically, each developer has their own private repository and they push to their own public repository, and then you have an integration manager that interacts with those changes from the developers by pulling from their public repositories. And the integration manager, it's a bit like a mini Dictator model, I guess. The integration manager is the only one who pushes to the authoritative repository, and then the developers know that they can pull directly from that. So to summarize, basically there's lots of great models. Git is incredibly flexible, so you can create your own, the one that works best for you. And DVCS, it gives you these options. So let's talk more about workflows. So what is not a workflow? A non-workflow would be where you are a developer and you make some changes on your code, make some more changes, and then of course something is going to break at some point, and you get unhappy about that. You try really hard to fix it, and then maybe it's fixed. So that is not a workflow. A bad workflow is one where all you do is create changes and then you commit them. That's sort of just autosave. You're not getting a lot of mileage out of that. A more basic one, which isn't quite as bad, is you create your changes, you stage them, and you actually review your changes, and then when they're ready, you commit. Some great pro tips for working with DVCS are commit early and commit often. These are the things you want to do. And you can commit units. Now what we're going to look at is widely accepted as a good workflow. You can see more details about this at the link below, NVIE, or you can just Google Git flow. There's also Mercurial flow. So the workflow itself is not specific to one tool, although it's not really feasible in systems other than distributed version control systems. It's not really going to be something that you can do with Subversion easily. But with Git and Mercurial, it is easy. It looks like a lot. Don't panic. We'll just look at each one individually, and they turn out to be pretty simple and helpful. So first, we'll talk about our primary branches. You have your master branch, which sort of always reflects your latest production-ready state. So these are your releases, what your customers are running around with, and that it always exists. And then you also have your development branch, and that also always exists, and it is sort of your latest state of development. If you have a continuous integration system, you would typically base it off this, and the changes you make, the updates that happen in development are always going to get pulled back into master, and this also always exists with this workflow. So here is a very, very simple interaction between these two branches. So you start developing, and then when you're ready for a release, you go ahead and cut that release by merging it into master and tagging it, and you just rinse and repeat. For each version that you want to release, you merge it into master and tag it. Fairly straightforward. So let's talk about secondary branches and start off by talking about feature branches, which are great. Basically, any feature that you're going to work on, you can very easily create a feature branch, and all your changes will be encapsulated there and not pollute your other public branches. Like the development branch and the master branch are typically public, but this would typically be private. I'm getting ahead of myself there. So you would branch this off the latest development branch, and then the flow is that you would always merge your feature branches back into development, and then you can discard when you're done, because once you're done with that feature, you don't need that branch anymore. And these can be short or long running, and typically these are only local to the developer repository, or maybe a couple developers would share it, but it wouldn't typically be something that you would publish to a public branch. And what's nice is with Git, you can use the naming convention is feature / and then whatever the feature name is, and then several of the tools will actually collect all the feature branches together, so you can see those very easily. So here's what a feature branch would look like. First, you would start off developing, and then you want to create a feature, and you just create a branch for a feature, and then you merge those back in. The no -ff there is don't fast forward, so you keep those separate, and rinse and repeat. And in the case of the outside branch there, it's a long running feature branch, and maybe you would merge that in more than once, or maybe just when it's complete. So that's what that looks like. More secondary branches. Release branches are something where you would have a release candidate where you would do things like you'd prep for the release by doing QA and bug fixes on that, and it sits as kind of a buffer between your development and your master branch. So this would be for maybe a larger project where you had more resources and more stringent QA requirements. Always a good idea nonetheless, but this is the workflow. So you would always merge that back into most master and development branch, and you can get rid of it once you're done. So here's what it looks like. You start developing on your development branch, you're ready for your release, and you create a release branch from the latest development snapshot. You might do some QA, some fixes, and you continue to reintegrate those changes into the development along the way. And then when you're ready for the release, you merge it into master and tag it and reintegrate all those changes into development. And then at that point, since we have all the changes, you can just delete that branch until you're ready for a new release, and then you create a new release branch. That's it. Another secondary branch, this is one of my personal favorites. A customer calls you up and says, hey, there's a bug with this version I have, and you are right in the middle of some developing some new world-changing feature, and you're very deep into it, and you have no idea what what version this customer is running around with, what it even looks like. So this is where a HotFix branch comes in. It's like a release, but you just use it for emergency problems. So you just go to your master branch, grab whatever version is the afflicted version, and make the fixes, and then you merge those both back into master and development. So again, very similar to release branches. The naming convention is HotFix / and then a pointer to whatever the bug was in your bug tracking system. So here we have a existing release, version 1.0 maybe, and then we branch from that and work on our hotfix, make the changes, then merge those back into both master and development. And then maybe you didn't fix the bug and you need to do it again. So that's what it looks like. But it's really, really handy to create hotfixes using this methodology. Another secondary support branch are support branches. These would be for when you have to support legacy versions of products. Someone cannot figure out how to update their Oracle system, and your new stuff only works with the latest version of Oracle. Would be an example. So it's similar to the other secondary branches. Secondary branches, but use it for legacy releases. So you grab it off master. You don't ever merge it back into anything, actually, so it's unique in that sense. You just continue parallel development. So in this case, definitely a picture is helpful. So you have your master branch, you're working on it, and somebody says, well, first of all, you create your secondary release, so your version 2.0, but then your customer says, hey, there's a bug in version 1.1 of your product, so you create your hotfix branch, but you don't really want to, you can't really merge that fully back into your secondary release branch there. So you create your support release branch and you tag it. And you can continue with that workflow. If more bugs come up with that version 1.x, you continue to fix them in your HotFix branch. Now, in some cases, you can cherry pick, or in some cases you might want to cherry pick the fixes back into version 2.0. And by cherry pick is a specific Git command, but basically you're not merging in the entire branch. You're just grabbing very specific changes out of there that are relevant to the current state in your 2.0 or 2.x. So that's how it works. Your long-standing support branch just continues to exist indefinitely, but on its own, and you would never merge it back into master because you don't want to or you can't. So it just lives on its own. So that is what this workflow looks like, and as you can see, each of these has their own individual features that are tremendously useful in certain situations. So just a couple notes real quick on public versus private workflow. Your public branches are things that other people obviously are looking at. So what you want to do is make those commits. When you do make commits and push to a public branch, you want to make sure they're succinct and well documented in a best case. It's good if they're linear, they don't reflect a whole lot of merge history necessarily, and these are not going to change. You don't want to rewrite public stuff, because then if somebody else had pulled from that, then things will get very confusing if you rewrite it and they try to pull from it again. So you should consider public branches essentially immutable, just kind of best practices there. So with public branches, you are working very hard to make them clean. With your private branches, obviously they're very malleable and you can do whatever you need to. These are typically only in your local repository. With best practice, you don't merge these directly into public branches. You would spend a little time cleaning them up, rebasing, squashing commits. So, if you have 100 commits for a feature, that makes sense locally, but for the public branch, especially if a lot of different people pull from it, you want to squash those together and just have maybe 1 or 2 commits that make a lot of sense and are well documented. So that is, a couple more notes. You would always create your private branch off the public branch, then you go ahead and iterate on your private branch, and again, this is just reiterating what we talked about. So to summarize, every project's different, and you can and should customize your own workflow for your projects. Branches are like Lego blocks. So what's great about Git in particular and other DVCS systems are that creating branches are as easy as grabbing some Lego blocks, and merging them together is really as easy as putting those Lego blocks together. So it's not a perfect analogy, but it is helpful to consider how easy it is to do these things. And then just a couple notes on workflows there. But that is it for this Git mini presentation on collaboration. Thanks for listening.